increasing and decreasing values or range of a function. What do we mean? If you have a function and you have a graph like this, or like this, for us to know which one is increasing, you can see if this is x and this is y. Same thing for this, x, y. When x increases, y also increases. That's why we know it's an increasing, the function is increasing. But for this place, when x increases, y decreases. So that place, it is reducing. So let's put it down. If we have x is less than x1 and fx is less than fx1, it means it is increasing. If x is less than x1 and fx is greater than fx1, it means that it is decreasing. That is, from this place now, if this place x here is less than x here, from this place to this place, you can see that y increases, that is fx, so it is increasing. Same thing, if you look at it here, x1, x increases, but y comes down, so it is decreasing. So that's how we define increasing or decreasing function. But how do we know? Viewing just expression for the function, and then we will be able to say, oh, this is increasing, this is decreasing. You cannot use that function to know it. But one thing that you can really observe is this. If you look from this place to this place, look at the slope. Sorry. You can see, when it is, for the range that it is increasing, the slope is positive. It might be reducing, it might be increasing. But one thing is sure, the slope is positive. Look at this one too. Slope is negative. So that's how we know. The real test for increasing or decreasing function is, for this place, the y dx is positive. For this place, the y dx is negative. The only thing you just need to do is, once we have the function, we differentiate the function. And once we find the function, if we are going to find for increasing function, we will do fx is greater than 0, that is positive. For decreasing, we will do fx is less than 0. So the result we get from this range, that is how we know when it is increasing and when it is decreasing. That's what it is. Let's do one or two examples to express. Now look at this. It says determine if the function x cubed minus 15x 15 over 2x squared plus 18x plus 8 is increasing. So we know the expression for the function minus 15 over 2x squared plus 18x plus 8. And we know that for increasing part, the y dx will be positive. So let's find the expression for the y dx first. 3x squared minus 15x plus 18. And then, for the increasing part, we can now say minus 5x plus 6. So, for increasing part, it means that for increasing part, it means that 3 into x squared minus 5x plus 6 must be greater than 0. That is, the y dx must be positive. Now, let's quickly factorize x minus 3. Now, let's test for the range where this the y dx is greater than 0. We have, for equal to 0, x equals to 2 and x equals to 3. Do you understand? The y dx is 0. The zeros of the y dx is x equals to and 3. Now, let of this, because since it is just 2, it's a quadratic equation, and you know how the curve will look like. It will go down like this. So, and this curve represents the y dx. So this place will be 2, this place will be 3. You can see from all before to 2, that is, let's say from negative infinity to 2, the y dx is positive. From 2 to 3, the y dx is negative. After 3 to infinity, the y dx is positive. That's one of the ways to test. So, from this, our results show that the y dx is positive from negative infinity to 2. Hence, it is increasing from negative infinity to 2. The y dx is negative between 2 and 3. Hence, reducing or decreasing from 2 to 3. So after 3 to infinity, it is y dx is positive. The y dx is positive. Hence, it is increasing. So you can see. So that is how it is. So this part is not required. These are the parts that is required in this as the solution to this question. So from infinity, minus infinity to 2, and from 3 to positive infinity. So once it is quadratic like this, you can go up, you can go down. You can do this test anyhow for it. So in the second one, I will use another test. Same thing we get. So I will use that one in the next question. Now we have this. It says determine the interval fx equals minus 3x raised to the power 4 plus 5x cubed is increasing. So just like the other one, we just do y equals minus 3x raised to the power 4 plus 5x cubed. So the y dx is equal to minus 12x cubed plus 15x squared. Minus 12x cubed plus 15x squared. So I can factorize it and say this one is x squared 3x squared into 5 minus 4x. Yeah. 3x squared into 5 minus 4x. And we know that for increasing, the y dx must be greater than 0. So we can now say, for the values we are looking for, 3x squared into 5 minus 4x must be greater than 0. Now let's test. And the zeros are x equals 0 and 5 over 4. So we have to test for less than 0. For x is less than 0. Also from x is greater than 0 for less than 5 over 4. And we have to test for 5 over 4 is less than x. That is the range you have to test for. So let's make it like this, to infinity, and this one from infinity. So these are the ranges we are testing for minus infinity to 0, from 0 to 5 over 4, and from 5 over 4 to infinity. So for this one, this is not quadratic. You can see this one is 2. So we are going to use the normal test we are going to use. So this one, we are going to put this like this. So here is 3, here is x squared, here is 5 minus 4x, and this place will be the product. 3x squared 5 minus 4x. Now, if x is a bit less than 0, so if x is a bit less than 0, let's say less than 0, because we don't have any range after this. This place will still remain 3. And this one will be negative. It's negative. So what is happening here? This one will be positive. If x is less than 0, x is negative. Times 4. That's negative. Times minus positive. This place will be positive. So it means that this product will be positive. This one times this one will be positive. Now let's see. So it means that it is positive before this place. Let's check for x greater than 0. When x is greater than 0, let's see. This place will be positive because it is positive now automatically. It is greater than 0. But sorry, when x is now greater than 0, but less than 5 over 4. So we have to be very sure of that. It is less than 5 over 4. This is the second thing we are testing for. Now, if it is less than 5 over 4, this one is going to be, let me see, positive. Yeah, it's positive. But by the time we work all this out, it's going to be positive. So this is going to be positive. You can see. Now, when x is now greater than 5 over 4, this base is positive. If it's greater, this base will be negative. So this base will be negative. So what we are now saying is that from infinity to 0 is increasing. From 0 to less than 5 over 4 is increasing. So 5 over 4. Yeah, okay. Let me say this. 5 over 4 to from 5 over 4 to infinity, it is decreasing. So we have found the range. The interval it is increasing. The interval it is increasing is from interval its increase is, let me see, negative infinity to 0 to 5 over 4. So it means that from negative infinity to 5 over 4, that is for x less than 5 over 4, it will increase. Simple. That's all. That is all. So from this table now, we can see that from infinity to 0 is increasing. From 0 to 5 over 4 is increasing. But after 5 over 4, it is reducing. Now let's talk about stationary points. What do you mean by stationary point? It's a point where there is total halt and change of turning, as in turning back of the curve. How do I mean? Look at this curve now. At this point, we refer to it as stationary point. Why? It's just like when you throw an object up. If you get to the point, to a certain point, stop and start coming down. Or if a vehicle is moving, for it to turn back, it must stop before it. So that's what we refer to as stationary point. Or if it is going like this, at a point it must like switch to halt and then change direction. In short, all my story is this. Stationary point is the point where the y dx is 0. Where the y dx, the differentiation of the function is 0. So, point where the fx dx is equal to 0. Those points are referred to as stationary points. And we have mainly 3 that you can discuss at this level. That's what I can just say. At this level, we have maxima or maximum, minimum, and point of inflection. simple. What is common to all of them is that they are the dy dx or the fx dx is equal to 0. That's the commonest thing. But for this one, is a peculiar type of stationary point. So we are going to deal with it in depth later on. So this is something you can find in all of them. For this one and this one, the fx dx is 0. For this one too, in certain instances, the fx dx will be 0, but not always. That's why I say we are going to deal with it in depth with time. Now, look at a curve like this. If we have y and x in this direction, and we have it like this, you can see. You know that this one is increasing. It's increasing here. I mean, at this point, it became 0. I am talking about the y dx space. You can see that the y dx is positive here, but the function is increasing. The y dx is 0 here. Here, it is decreasing. Here, 0. Again, moving on. We can see that in this place, the y dx is positive. The y dx is negative from what we just treated in increasing and decreasing form. So we can use that one to carve out the curve as well. Let's make it like this for ease. So we can see now. So since this one is increasing, the y dx is increasing. Since this one is increasing, since this one is increasing, the y dx is positive, but it is reducing. See, at this point it is 0. So that it won't be like I am doing one magic. You can see it is 0. And it starts getting negative. And then it comes back. It becomes 0 again at this point. So what is important in this thing is that this curve is positive when it is increasing, 0 at the point, at stationary points, negative while it is reducing, and then positive while it is increasing. Let's go on. So you can see. Let me make this place point of inflection. Sorry. So if you look at it, from what I have drawn, this place is maximum, minimum, point of inflection. This kind of thing, we encountered it in the motion. That's why I put that motion first, because it's something we observe every day. We observe it in motion too. So you can see it got to a point like this. This thing can be used to determine so many things, predict so many things. Now, if you look at this curve now, this is the y dx. Let us now look at the 2y dx squared. How will it look like? See, it is reducing now. So you can see that the 2y dx squared will be negative. Sorry. It is reducing. The 2y dx squared will be, can see, will be negative. And it is increasing now. It's positive now. See. This is the turning point for the y dx again. It comes down. And for this one, now let me illustrate this with the diagram. Let's call this x, y. Let's draw a curve to represent, and this is the point of inflection. You can see. Now, from our knowledge, we know something about the y dx. When it is increasing, the y dx is positive. When it is reducing, the y dx is negative. So you can see this one is increasing. After this place, it is reducing, so it is negative. All this place is negative. You can see it's negative. Now, it's positive. It is still positive, and it continues to be positive. You can see it just turned there. So, just coming to this place, and that's what happened to the y dx. Now, we will now draw the two y dx squared, considering the motion of the y dx. You can see. So, in this place, the gradient is reducing. So, since it is reducing, it means it is negative. It is negative. So, let's draw it. You can see. For this one too. For this one too. It will. You can see it is positive because it's increasing here all through. It is positive. Now it comes back to negative. It's negative. How you see? You can see. But for this one, point of inflection, it just became 0 and turned back again. It did not get into negative. So you can see, take note of this point. For this point of inflection, the y dx did not come into the negative part. It did not change sign. It just continued in the positive. If it is from negative, it will continue in the negative. Take note. So that's what we have in this place. So with this, we can say some things about minimum, maximum, and point of inflection. Considering this graph, for all of them, I told you, point of inflection is a special point. It might have the y dx to be 0. It might have it, but not in all situations. We treat that one separately. So the y dx, when it is for all points of this thing, for all points, stationary points, is equal to 0. Is equal to 0. Please, not necessarily 0 for. Okay, let me just restrict myself to. Now, because point of inflection is a special point, I will concentrate on minimum and maximum points for now. For minimum point, maximum point, the y dx is equal to 0. For minimum, maximum. And we also note something. There is increase in the function before getting to the maximum point, and decrease in the function before getting to after maximum point. There is decrease, there is increase in the function before maximum point, and decrease after. What are we saying? Before maximum point, before maximum point, the y dx is positive. After maximum point, the y dx is negative. But at maximum point, the y dx is 0. So this is one way of testing. After you have discovered that the y dx is 0, you will test. Before it, what is it? After, what is the sign? That's how you confirm this one. Look at it again. For minimum, you can see it is decreasing before getting to minimum and then increase. What does that say? It says for minimum, let's start from this one. The y dx equals 0. Before minimum, the y dx is negative. After, the y dx is positive. That's one. Now let's now go to the 2y dx squared. The 2y dx squared. If you look at it, at this point, it is negative. At this point, it is positive. You can see. This one changes sign. So that is another test. So now let us see if we want to use the 2y dx have shown you two ways of testing for maximum and minimum. It is by increasing before getting to maximum, decreasing after getting to maximum. That is, the y dx is positive before getting to the maximum point, negative after getting to the maximum point. For minimum, it is negative before getting to the minimum point, positive after minimum point. Another way you test is by using the 2y dx squared. If it is minimum point, the 2y dx squared is positive. That is simple. That's all. Now let's do an example, one or two examples to confirm. Look at this. You have to find the maximum and minimum values of the function 2x minus 1 over x squared plus 2. So we have this. Let's take it. Y equals 2x minus 1 over x squared plus 2. And we know that the first thing is to find the stationary point, which can be maximum, minimum, or point of inflection. To do that, we have to find y dx equals 0. So how do we do this one? We're going to x squared plus 2 into 2 minus 2x minus 5 into 2x over x squared plus 2 whole squared. And this one is going to give me 2x squared plus 4 minus 4x squared plus 2x over x squared plus 2. I'm going to have 2x plus 4 minus 2x squared divided by x squared plus 2 whole squared. And this is equal to minus 2 into x squared minus x minus 2 over x squared plus 2 whole squared. So if I factorize this, it's going to give me minus 2 into plus x minus 2 over x squared plus 2 minus 2 into x minus 2 plus 1 into x minus 2 over x squared plus 2 all squared. And that is equal to minus 2 into x plus 1 into x minus 2 over x squared plus 2 all squared. Now, for this, we can see that the stationary points are x equals minus 1 and x equals 2. Now to differentiate between maximum and minimum points, let us use our sign to test. That is, before maximum point, it is positive. The y dx is positive and negative after maximum point. I won't be able to use that graph because of the denominator. Now let's do that. So I have this. Minus 2. X plus 1. X minus 2. So I have minus 2 into x minus 1 plus 1 x minus 2. So now, for x is less than minus 1, I have minus 2 here. If x is less than minus 1, like minus 1.1 or minus 2, this place will be negative. This one too again, if x is less than minus 1, you subtract 2 from it, this place will be negative. So, negative times negative times negative, this place will be negative. You can see. When x is greater than minus 1, when it's greater than minus 1, and you add 1 to it, like minus 0.9 or whatever, this place will be positive. Minus 0.9 minus 2. What does that give? That one is negative. So by the time we do this one, minus, so this one is positive. So as we have said it before, test for 2. Let's test for 2. When x is greater than 2. So sorry. When x is less than 2. It's less than 2. If it's less than 2, we're not up to minus 1. Let's see what it will be like. Let's say like 1.5. This place will be positive. And this place will be negative. What happens here? This place will be positive. Now, let's test again for this place. Like, when it's greater than 2, like 2.5, this place will be positive. And this place too will be positive. So, minus, positive, positive, this one will be negative. What does that mean? If it changes from positive to negative, that means it is a maximum point. So 2 is maximum point. So now I can now write my result here. X equals minus 1 is a minimum point. And x equals 2 is a maximum point. So these are ways to test for stationary points, minimum, maximum, and then point of inflection. We go to point of inflection quickly later on.